Hello and welcome to the lesson video notes for lesson 6.5, conditions for special parallelograms. Today's objective is to prove that a given quadrilateral is a rectangle, rhombus, or a square. Alright, last lesson we looked at the properties of rectangles, rhombuses, and squares, and now we're going to verify that quadrilaterals are these given shapes based on certain conditions. First, make sure that you've done the vocab in the notes and in your vocab book. Once you are done with that and ready to begin watching the video, make sure you've done the warm-up. When you are ready to continue, the answers will be displayed. If you need more time, just pause the video. Alright, for A, find the length of AB when A is at -3,5 and B is at 1,2. We need to use the distance formula here. In doing so, we get that it's 5. Secondly, find the slope jk for j at -4,4 and k 3, -3. We'll need to use a slope formula. In doing so, that slope is -1. Number 3, justify each of these statements that angle ABC is congruent to angle CDA. Well, these are opposite angles in a parallelogram, and that means they are congruent. AEB is congruent to CED by the vertical angles theorem. Alright, our first part of this lesson is talking about conditions for rectangles. There are two main conditions for rectangles, and I'm not going to read every single part of this. If we have a rectangle, or if we're trying to say that a quadrilateral is a rectangle, one way to do so is to show that we have one right angle in a parallelogram. So if we know it's a parallelogram with one right angle, it has to be a rectangle. Secondly, if we have a parallelogram with the diagonals congruent, then it's a rectangle. Notice the first part of these givens, in both cases, are the assumption that it is a parallelogram. Alright, once we know it's a parallelogram, we can verify that it is a rectangle based on the other part of the criteria, either one right angle or diagonals that are congruent. So let's take a look at example 1. A manufacturer builds a mold for a desktop so that AB is congruent to CD, and BC is congruent to DA, and the measure of angle ABC is 90 degrees. Why does this have to be a rectangle? Well, we can see that there's 4 sides, so it's a quadrilateral. We need to show that it's a parallelogram with this one right angle. That's what these first two pieces show us. So here's what we should know. Both pairs of opposite sides are congruent, so it's a parallelogram. Since we have a right angle, we have a parallelogram with one right angle, that makes this a rectangle. Here are 3 more conditions for something being a rhombus. Again, we're starting off with the given condition in each one that they are parallelograms, not just quadrilaterals, but specifically parallelograms. So if we have a parallelogram with one pair of consecutive sides that are congruent, then it's a rhombus. If we have a parallelogram where the diagonals are perpendicular, then it's a rhombus. If we have a parallelogram where the diagonals bisect a pair of opposite angles, then it is a rhombus. In order to apply these theorems, the quadrilateral must be a parallelogram. To prove that a given quadrilateral is a square, then, it's sufficient to show that the figure is both a rectangle and a rhombus. That's how we're going to verify that something is a square. If I can show that a parallelogram is a rectangle and a rhombus, then it is concluded that it is a square. Remember, you can also prove that a given quadrilateral is a rectangle, rhombus, or square by using definitions of special quadrilaterals. Alright, in example 2a, we want to state whether or not this conclusion is valid or not, based on the given information. So here's what we are told. EF is congruent to FG, and EG, this diagonal, is perpendicular to FH. So that's a right angle. We want to conclude that EFGH is a rhombus using that given information. That EF is congruent to FG, that means a consecutive pair of sides are congruent, and EG is perpendicular to FH, that means the diagonals form a right angle. This conclusion is not valid, and here's why. By theorem 653, which states If one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. By theorem 654, if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. To apply either of these theorems, you must first know that ABCD is a parallelogram, and we simply are not given the right information to verify that that's a parallelogram first. So this is why this is not valid. Now, before you write all of this down, focus on these things. We are not told that it is a parallelogram. That is the reason this is not valid. Let's try 2b. Again, in order for these conditions to be true, we must know that it's a parallelogram first, or be able to show that it's a parallelogram first. So this is the conclusion we are testing in example 2b. EFGH is a square. Well, here's what we're given in this example. We are given that EB is congruent to BG. We are given that FB is congruent to BH. We are given that EG is congruent to FH. That means the diagonals are congruent. And we are given that triangle EBF is congruent to triangle EBH. Remember, that means their corresponding parts are also congruent. So step 1 is to determine if it's a parallelogram. We are given EB and BG are congruent and FB and BH are congruent. That means the diagonals bisect each other, so it is a parallelogram. So all the other conditions that we've learned in this lesson are true. Now we're going to determine if that parallelogram is a rectangle. Well, we're given EG is congruent to FH. Those are the diagonals, and a parallelogram with congruent diagonals is a rectangle. That means it is a rectangle. Now, we also need to determine if it is a rhombus. Remember, to determine whether or not a quadrilateral is a square, we need to show that it is a parallelogram that is both a rectangle and a rhombus. We are also given the triangles are congruent, and that means their corresponding parts are congruent. So EF and EH are congruent. That means we have a parallelogram with one pair of consecutive sides that are congruent. So it's also a rhombus. Since EFGH is a rhombus and a rectangle, we can conclude that it is a square by definition. All right, let's take a look at example 3a. In this example, we are given a parallelogram, so we know that condition is met first, with given vertices, and we are asked to classify it as a rectangle, rhombus, or square, naming all that apply. So if it's just a rectangle, that's all we write. If it's just a rhombus, that's all we write. But if it's both a rectangle and a rhombus, we also say that it is a square. We are given that it's a parallelogram, so we don't need to start with that. Step 1 is to take these coordinates and plot them in the graph and connect them to form our parallelogram. Once we've done that, we're going to take a look at the diagonals, PR and QS. Remember, the diagonals of if the diagonals of a parallelogram are congruent, then we know it's a rectangle. So what we're going to do is find the length of PR and QS using our distance formula and see that they're the same length, so we can say that they're congruent. If you do this, you should get PR is root 26, and QS is also root 26. Since root 26 equals itself, the diagonals are congruent, and PQRS is a rectangle. So we know that it's a rectangle. Okay, this is what you would need to show. You would need to show that PR is root 26 using the distance formula, and QS is root 26 using the distance formula, and then you'd write a statement like this, or since PR equals QS, or you could use the therefore symbol to say the diagonals are congruent. Therefore, it's a rectangle. Now we're going to determine if PQRS is a rhombus. In order to do this, we need to remember that in a parallelogram, if the diagonals are perpendicular, then the parallelogram is a rhombus. So we're going to find the slope of the diagonals, PR and QS, to see if they are opposite reciprocals of one another. Remember, that's what it means for lines in the coordinate plane to be perpendicular. If their slopes are opposite reciprocals, then they're perpendicular. So what I would like you to do first is find the slope of PR and the slope of QS using your slope formula. All right, we should get the slope of PR is negative 1/5, and the slope of QS is 5. These are opposite reciprocals, which means that if I multiply them, I get negative 1. That means PR is perpendicular to QS and PQRS is a rhombus. Since we've shown that PQRS is both a rectangle and a rhombus, we can say it's a square by definition. Alright, why don't you take a moment to try example 3b. These are the steps you're going to follow. You're going to graph the figure first. It should get something like this. And then after you've graphed it, you want to check and see if it's a rectangle, rhombus, and then if it's both, you can say it's a square. Here's the things you should check for. To show that it's a rectangle, we're going to show that the diagonals are congruent. If they're not congruent, then it's not a rectangle. To show it's a rhombus, you're going to see if the diagonals are perpendicular using their slopes. If they're not, then it's not a rhombus. Alright, if you need more time, pause the video, but otherwise, this is what we should have. Looking at the diagonals, they're both, one is 3 root 2, one is 5 root 2. Those are not equal values. Those are not congruent. That means the diagonals are not congruent, so it is not a rectangle. But I can still check and see if it's a rhombus. Remember, because it's not a rectangle, I know it's also not a square. So let's determine if wxyz is a rhombus. We're going to check the slopes of the diagonals. The slope of wy is -1. The slope of xz is +1. These are opposite reciprocals of one another. If I multiply 1 by -1, I get -1. That means the diagonals are perpendicular. Therefore, it is a rhombus, and that is the only conclusion we can make. Alright, on example 3c, again, why don't you try it yourself following those 3 steps. Graph the parallelogram. Check to see if it's a rectangle by looking to see if the diagonals are congruent using the distance formula. Check to see if it's a rhombus by looking at the slopes of the diagonals to determine whether or not the slopes are perpendicular. If it's both a rectangle and a rhombus, then we can say it's a square. Pause the video if you need more time. Alright, let's take a look at what we should have gotten. The diagonals have lengths 2 root 17 and 2 root 17. Since the diagonals are equal or congruent, it's a rectangle. Then we're going to check the slopes of the diagonals, 1/4 and -4. Those are opposite reciprocals, and the product is -1. That means the two segments are perpendicular, so it's also a rhombus. To determine if it's a square, let's remember the two things we've just stated. Since PQRS is a rectangle and a rhombus, it has 4 right angles and 4 congruent sides, so we can conclude that it's a square. Again, a parallelogram that is both a rectangle and a rhombus has to be a square, so PQRS is a square. The 3 answers we would be looking for are rectangle, rhombus, and square. Alright, that concludes our examples here. If you have any more questions, feel free to ask during class when we all get back in class together. And I have attached the assignment to go along with this. Please feel free to get started on that if you have any extra time. Otherwise, we will take a look at lesson 6.5 during class.